Okay, so example 4 says list the intervals on which function is increasing or decreasing. So part 1, we are given the function fx, which is 1 plus 8x squared minus x4, and we want the first derivative, and we need to know what makes it 0, what makes it undefined. So 0 plus 16x minus 4x cubed, and that's the same thing as saying, let's say factor of 4 and an x out, and that would give us 4 minus x squared, and that's the same as saying 4x and then x minus 2, well, rather 2 minus x and then 2 plus x, because we're factoring. And what makes the derivative equal to 0? What makes it undefined? So f prime of x equal to 0 when the x is 0, or the x is 2, or the x is negative 2. So basically each one of the parentheses will be 0. This one happens to be 0 when x is 0, this one will be 0 when x is 2, this one will be 0 when x is negative 2. And those are the numbers that I'm basically writing, and one of them needs to be a negative 2. So let's say the last one, negative 2. Perfect. And now what makes the f prime undefined? Let's go ahead and think about that. What makes it undefined? And it's literally impossible for the f prime to be undefined because there is no denominator on this fraction, or there's not even a fraction to begin with, so there is no solution here. Okay, so let's do the first derivative test next and investigate which one of these numbers is going to be a maximum or a minimum. So my first derivative test yields the plus minus, and this means that the function f is going up, then it's going down, then it's going up again, and then it's going down. So it kind of like looks like this. It's going up, then down, then up, then down. So that's the shape that I imagine when I'm seeing all these pluses and minuses. And so that's pretty much the end here. This gives us that we have a maximum and we have a minimum, and then again we have a maximum. Okay, so the question was on where the intervals where it's increasing or decreasing. So let's go ahead and write that down. F of x is increasing on negative infinity to negative 2 and 0 to 2, and it is decreasing on negative 2, 0, and 2 to infinity. So again, it's increasing on this interval and this interval, so that's why I'm writing that answer, and it's decreasing on the other intervals in the middle. So from negative 2 to 0 you were decreasing, and from 2 to infinity you were decreasing. That's why I'm saying this down here. Okay, so that's the answer to the question for part 1. So part 2, I believe, said what are the maxes and mins. So we already did all the work. All we have to do is just write it down. We already see it from the line that I made, that x equal to negative 2 and positive 2 have a max, and the x equal to 0 has a minimum. And so we are finished in part 2 also. Okay, so that whole thing is actually the answer. Okay. Now, part 3 says find the places where we have concavities up or concavities down. So in order to do that, we need the second derivative. And again, to find the second derivative, I'm going to choose this to differentiate. It's the fastest one, the easiest one to find the derivative from. So you know what? I'm going to just go ahead and do this. I'm going to copy that to the bottom down here. And this is going to be part 3, basically. So part 3 says find the concavity. So here we go. That's the f of x, f prime of x. And so what is the f double prime? So the f double prime is going to be 16 minus 3 times 4 is going to be 12 x squared. And we can factor a 4 out. And if we did that, we end up with 4 minus, let's say, 3x squared. We need to investigate what makes it equal to 0. And this happens when the 4 minus 3x squared itself equals to 0. So this is true when 4 is equal to 3x squared, which means x is going to be, x squared is going to be 4 divided by 3. So x is going to be a little bit funny looking here. It's going to be the square root of 4 divided by 3. And you can reduce it, you can do whatever you want. I'm fine with this. And don't forget the plus or minus, there are 2 values. Is it possible for the f double prime to be undefined? The answer is no. F double prime cannot be undefined because there is no denominator. So let me write that down. Okay, so there it is. It cannot be undefined. So let's go ahead and draw the line and pretty much wrap this problem up. Okay, so there we have it. The line is drawn right now, and we're going to test some values. I don't know, let's say negative 10 and 0 and positive 10. We're going to take those guys and put them into the second derivative equation. So the second derivative is one of those. Pick whatever one you want and put in negative 10, put in the 0, put in the 10. And I believe if you did that correctly, you're going to end up with a negative, a positive, and a negative. Typically speaking, we end up getting rid of these green numbers. They don't really matter. We just have to have them in order to test. Now, having a second derivative that's negative means that the function was concave down, and here the function is going to be concave up, and finally the function is going to be concave down. So let's make a record of where the function was concave up or down. So fx is concave up on, let's say up, on the interval from negative the square root of 4 over 3 to positive square root of 4 over 3. And it's concave down on the interval and, the other intervals. So there it is. Again, it's concave up in the middle, so that's why I'm writing this over here, and it's concave down on the edges. So that is the reason why I decided to write this answer over here. Okay. Hopefully that made sense. And finally, the inflection points. So where are the inflection points? Seems like right here, and there's an inflection point, and also on 4 over radical 3. So yep, that's it. So let's see, what are we missing? Part 4 says, part 4 says list the inflection points, and finally part 5 is going to be the graph. Okay, so let's make the inflection points. So part 4 is going to be to write down the inflection points. So x equal to negative square root of 4 over 3 and x equal to square root of 4 over 3 have inflection points. And now we kind of have to summarize everything and make the graph. So let's try to do that together here. Let me make the xy plane, and we're going to put everything on this page. Okay, so here's the xy plane. We're going to try to put in the critical numbers from the first derivative and the second derivative. So what were the critical numbers on both of these derivatives? Let's check back. And the first derivative critical numbers were -2, 0, and 2. So let's say -2, 0, and 2 are places like this. So -2, let's say, is over here, and 0 is going to be right there, and +2 is going to be over here. So these are the places where we had a maximum, a minimum, and a maximum. So again, I don't know if the minimum is going to go down here or down here. I haven't really investigated, and I really don't know what the maximums are, but I know that there's a maximum and a minimum, a maximum. And somewhere in between at -4 radical 3, so I don't know how much that is, we'll find out in a second with the calculator. And at 4 radical 3, we have an inflection point. This is a place where the concavity went from being down to being up, basically, or vice versa. Okay, so same thing happened over here. It went from being, I don't know, up to being down, maybe, or something like that. So we'll investigate, and we'll graph the function over here on this page. So let's go ahead and do that. So when I put -2 in my calculator into the function f of x, I got f of -2 to be equal to roughly 17. When I put in the 4 radical 3 with the negative sign, that's roughly -1.15. So negative square root of 4 over 3 is roughly -1.15. The answer turned out to be, roughly speaking, 9.8, and so on and so forth. So 0 gave me a 1. The 4 radical 3, radical 4 over, let me do this again. Square root of 4 over 3 gave us, again, 9.8 roughly, and 2 gave us 17. So it seems like all the numbers are going to be pretty big. So let me lower this down a little bit so that we can kind of get a good picture here. Okay. Yeah. So -2 gave me a 17. So let's say 17 is up here somewhere. This is 17. -4 radical 3 gave me 9.8, so like, let's say right about 10, so let's say this is 10, so it's going to be over here. And 0 gave me a 1, so let's say this right here is 1, so that's where the function is going to be at that point where the minimum happens. Then again 9 over 8, 9.8, and again at 2 it was back to 17. And it was going up, then down, then up. So it was going up, then down, then up, and then down again. So that's kind of the graph. And the concavity was down for the first part, up for the middle part, and then down again for the last part. So putting all this together, we end up with a graph that sort of kind of looks like this. So you're going to be concave down to the inflection point. You're going to switch concavity, and you're going to be concave up, going through the minimum. So let me do this again. Here we go, going through the minimum, and you're concave up this time, and then you're going to be concave down again. So that's kind of the general idea of the graph. Obviously the calculator can do this a whole lot better, a whole lot smoother. So, you know, I would advise you to look in the calculator and kind of see what the graph looks like. So, but that's the general gist of things, basically. Okay. So I hope that was clear, and let's go on to the next one. Okay.